Hey everybody, this is Larry. This is Q3 of the recent Leetcode contest. If you stay to the end, you'll watch me solve it live during the contest. Hit the like button, hit the subscribe button, join me on Discord, and let's get started. Minimum number of function calls to make target array. So you have this function, which is actually like, I don't know why they wrote it like this, because they could just literally just give you the definition of two functions, which is one, you have basically two functions you can do. One is to increment by one, and then the second one is by doubling, right? So this one took me a little bit of time just to think. I spent about 4 minutes, but most of that was just thinking because the code ends up being really quick. Yeah, so how do I solve this? So let's think about this one number at a time. And I actually, to be honest, I sorted this during the contest. It's not necessary. For me, I just figured maybe there's a way to reason about it, but actually it wasn't necessary, so I wouldn't worry about it. And again, you can see that it doesn't matter in terms of whether it gets accepted or not. But let's say you have a number like 5, right? So the binary representation is 101, right? Or 7, which is 111, and then say, I don't know, 11, which is, my math is not as good, so something like that, maybe? Well, the question is, how many operations to do this one, right? Well, in minimally, you need to plus 1. At the very least, you know that you have to use the first operation twice because they're two ones, right? And then you could just double them. And like, playing around with binary numbers, the obvious quote unquote way of doing it, and you should prove to yourself at home, is just to construct, you start at 1, you double it to 10, and then you add and then you double it again to 100, and then you add 1 to 101, right? Similarly, you go 1, double it, and then go to 11, double it, and then 111, right? And so forth. So you can kind of see the pattern of how you want to do it individually. But in this case, of this problem, I'm not going to draw this out because I'm lazy. Okay, I guess I am. Maybe I'm not that lazy. But yeah, so you get the pattern here, right? For each individual number, but that's not enough for this problem, right? The problem is that you have to, for operation 1, the second operation, you have to multiply all numbers by 2. So you do all the shifts together, right? So that means that, for me, the way to figure that out is that actually, well, the adding ones, you cannot do it together, but the doubling, you could always do it together. So basically, your doubling is going to be affected by the number of time, the most number of times you double. So basically, that's my strategy of solving this problem. Is that I have a count for a number. This is for the number of ones that we have to add, and there's no way around it. So you just count them all up. And doubling, we just keep track of the max of the doublings by taking it half. The number of times you count by half, which is the reverse way of it. For example, you know that for 5 and 7 we have to double it twice. So then that means that that's all you have to do. That means that's 2. But if you add 11 to the list, you know that you have to double at least 3 times. So that's how you would and then that's how you kind of count the max double in that case, and then use them all together, right? Because if now, let's say you're constructing them together, well, first of all, you would pad a 0, I guess. So in the first set of moves, you would just add 1 for the 11th, and then you double to 10. And then now on the second digit, basically we're doing it digit at a time, so let's convert this to 0. So then now the second digit, you add 1 1, and here you do 10 and don't add a digit, and then so forth. So that's how you kind of do it digit by digit, and just count the number of digits in binary, minus 1, because I guess 1 digit, you don't have to double it. So that's kind of my solution for Q3. I actually take this problem, it's cute, and I had to really think about what to do in this farm. So it was cute. Anyway, hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this farm. Did you like it? How did you solve it? Was it another way? And I will see y'all next farm. Bye bye. Okay. Slow testing today. Hey everybody, yeah, thanks for watching the video. This is probably after you watched the live portion of the solving during the contest. Hit the like button, hit the subscribe button, join me on Discord, and I will see you next contest. Bye bye.